So you don't have
There you
to
go.
worry about getting your seat taken again.
Okay. So first, let's discuss what a median is. A median, not to be confused with the thing in the middle of the road, which is also called a median. You knew that? Like middle of the road divided into two sides of the road is called a median. This is also called a median, but it's different. Similar, but different. It's a segment whose endpoints, let me go over here and make sure I'm filling in the right things, whose endpoints are a vertex. One endpoint is a vertex of the triangle, and the midpoint, in the midpoint of the side opposite the vertex. So the two endpoints of the segment, that's called a median, are one of the vertices, a vertex of the triangle, there are three of them, and the midpoint of the opposite side. So this is the opposite side from this vertex, and it's the midpoint of the side. We can see that by it's congruent and it's labeled midpoint. So this line here would be called what? Our median. Very good. And when I say it's somewhat similar to the idea of a median of the road, is that a median of the road is usually going to be in the middle of the road, right? So it's going to be at the midpoint of the road if you go the width of the road. So that's kind of the similarity there. But other than that, that's really it. That's only similarity. Otherwise, it's just a unique geometry concept. Questions on that idea and concept? Hey, guess what? We're going to be doing more construction. Woo! Yeah, construction. Yeah, woo! Construction. Woo! Yeah.
No, I hate this.
There it is.
That's too bad.
Just copy the point. You don't need to use the tool.
You go so fast.
Can I get a volunteer to pass out these rulers? Okay. Haley, raise your hand. She's closer, so I'm just going to choose her. Okay.
Did you find your meter stick in the ruler jar?
You know what?
I did. Yeah. I'm like, yes, Jacob. I knew.
What?
Hey, are these compasses toys?
Yes.
They are not toys. You don't play with them. They are sharp. You get hurt. It's Play-Doh.
If they're bright colored,
No.
take one step forward.
That's right.
You get that gas reference. Dancing on the tightrope. Right after we walked up the
Throw a puppy.
Why do I have a clip?
Last time you saw it.
I have, you know those,
Hey, Haley.
Okay. If anybody was listening up, please and thank you. Thank you. That was okay. That was an average one. We can do better. Thank you. So we'll start off. We will place a compass on one of the endpoints of one segment. So we pick a segment and put a compass there. So we pick a segment, we put a compass there. So let's just do the top segment. Okay, let's just choose the top segment because we're supposed to construct a median from x to y z. So actually, my bad. If we're doing from x to y z, then we would need to do the midpoint of this y z side. So we need to do this segment from y to z. Okay, because it says the median is going from x to this. We need to find the midpoint of this. So what we're going to be doing is we're going to be constructing a segment that goes through the midpoint. We're going to be finding where the midpoint at is with this. So it's very similar to what we did with our perpendicular bisector before. So we'll put the endpoint, or we'll put the compass, on the endpoint of y, z. So we'll first put mine on y. And we need to choose a setting that is over half the length of the segment. And you draw an arc, like so.
Just like roughly around that.
It needs to be over half. So as long as it's over half, but less than full, will be good. Okay? Then you go to the other endpoint of the same segment. So what's the other endpoint of YZ? Z. Very good. So we'll go over here, we'll put it on Z. And we'll choose the same exact setting. It has to be the same setting as you did for the first one. And we'll draw the arc again. And you should have two intersections. this one, we'll go through. And we'll mark this as well. For this one, you don't need to go super overkill. For this one, you don't need to go super overkill like we did before. You don't need to go like super long each direction.
I
Go on,
figured that out. You could have said that.
What did you do?
Aw.
Which point did you just do? Oh, you just,
These two intersections. I connected the two intersections.
I didn't do this right.
This one. Is that good?
Yeah. Oh, but I did it from eggs.
Aw.
Okay. So that's just even a letter at this point. Hey, so what we did was we created a perpendicular bisector. But we didn't need it to be perpendicular for our function, but we created a perpendicular bisector. If you recall, we did this exact same thing before when we were constructing the perpendicular bisectors to find the circumcenter. Circumcenter was where three perpendicular bisectors meet and find one. But now, we needed the bisector because we needed to find the midpoint of YZ. So this is the midpoint of YZ, meaning that it cuts this in half. Because the median goes from the vertex to the opposite side. So if it's going from X to YZ, we had to find the midpoint of YZ. So then, to actually construct the median, you'll just connect the vertex X that we're doing to the midpoint that we found. To the midpoint we found. And this one is just a segment, so we actually don't need to have it. Okay, if you need help on this one, now's the time to ask.
Is this right? Does this look right?
Does this look like?
Yeah.
I'm kidding. I think I failed. Oh, God. How was the top? Yes.
But other than that, there's nothing else to that. So just learn what you're on.
Yeah, well, grades
No.
are technically together.
Okay, Aubrey, you had a question for me, please?
Yeah, I just want to know if this is right.
Love you.
I got the years now.
Yeah, that's good.
I can
Okay.
have grade 10. I mean, grade 10.
Woo!
Double overtime. You do look
Okay.
like the guy from the.
We could do such a good video.
Haley, you want to toss me my pen?
Harrison was ready to score.
Oh.
So I texted him and I'm like, what's the score?
Okay, next one. Hey, so just like we've done all the others where we went through, we did it once, and then we're going to do it on all threes for the triangle. We're going to do the same thing. So, this can get a little bit messy.
Yeah.
You have to be careful here, okay? You
Keep
have
it
to be
forward.
careful here, okay? So, what I'm going to do is I'm going to first go through. I'm going to make this smaller. You might have different points. Okay. So if we start with, let's say, the top, or sorry, we're making perpendicular bisectors for segments. So we need to find the midpoint of the segment, which we do by making the perpendicular bisector. So let's choose this top right segment for first for grins and giggles. We can choose any segment. Let's choose the top right one to find that midpoint. So we'll put the top right segment, the upper right segment.
Only one.
There's only one upper right segment.
There's
So-
only one up.
So we'll put it on the top vertex, and we'll choose a setting that's over half of it. As long as the setting's over half of that length, we'll be fine. And we'll swing through and make an arc.
Then you go to the bottom one.
Then you go to the other end point of that same side, use the same exact setting,
Another one.
they call it. So I accidentally goofed up and I didn't make mine over half, so I need to go back and make mine bigger.
Does this look like Thursday dream? No. On that art yet. Oh, sorry. I'm not.
Okay? And so you should get an intersection on that one. What this did is when we connect this line, it'll create the perpendicular bisector for this side. Can I make mine?
No, but guys, if you really want to know what happened, Kaylee moved schools. She got mad at me.
No,
Oh,
everyone in the
Everyone's gonna be
Oh
confused.
my gosh. You know, we lost like what,
I'm
a
just
day?
weird.
A day. Yeah, I just left it.
She had a bola.
Yeah.
So once you have this midpoint, once you have the midpoint, it's the point we really want from this. Once you have the midpoint, we'll connect this midpoint to the opposite vertex. So the opposite vertex is going to be this one over here. So I'll connect this midpoint to the opposite vertex. This will construct our median.
What's the opposite?
The vertex that's across from it.
Bottom, what's the opposite vertex of the top one then, the top angle?
The opposite side of the top angle is this. Because this is the side. The opposite
Yeah.
vertex is the vertex across from it. So this each side touches two vertices. And doesn't touch a third. Once again, we just need to make these segments endpoints.
Hello, girls.
Okay, question on the first one. Josie.
Dang it! This Stacy.
Okay, so now what we're going to do is we're going to make them for the other two as well. So we need to choose a different side. So we chose the top right side, and we found the midpoint of that. So now we need to choose a different side. You guys want to do top left or bottom? Okay, or bottom first, we'll do bottom. We're going to do both either way. So you'll put it on the vertex, and you need to choose a setting that's over half. Oh boy, I can't get over half on this thing.
It's alright.
So, we'll go to the top left. For me to choose a setting that's over half. Go to self, make this smaller for next class. And we'll go and do the same thing. Choose a setting that's over half. And you make sure you keep the setting the same for both sides. Oop, and not move it like I did.
I made mine so big. Like,
Yeah.
I don't even know what's going on.
me neither. I mean, know what's going on.
So once we construct that midpoint, we will take this midpoint and connect it to this opposite vertex. It's the one vertex this side doesn't touch. It's like the opposite angle. Remember we're talking about opposite sides or opposite angles? Okay, we were doing that when we ordered it from
Is
least
that
to
like
greatest.
that thingy?
Yeah. What that meant?
Like, you know where it's
So-
like,
See how this vertex, this side right here, it touches 1, 2 vertices, right? But it doesn't touch how many? 1. That's the opposite one.
Wait, for the
This
last,
side touches 1, 2 vertices.
for the last
So what's the one it doesn't touch?
the other one.
So that's the opposite one.
Yeah.
Okay, what again?
for the last angle after you draw that, you from the top angle, don't you draw it through the midpoint of those two?
You'll do the midpoint of the bottom segment. So now we did the midpoint of this top left and the top right segments. So now we would need to find the midpoint of the bottom segment. We would need to find the midpoint of the bottom segment. Now my compass is not big enough to do it on this. My compass isn't big enough to do it on this, so I can't. You guys can. I want you guys to do it on yours though.
Ow.
Okay, so just like we found the midpoint of these, you create a perpendicular bisector. So you put a setting from here,
Oh, I see.
that's over half of it. And go over here, same setting, over half of it.
Your desk isn't crowded at all. What do you even need? I was about to be really offended for her. I feel like it's all supposed to match up in the center.
Yep.
But mine doesn't.
Yeah, mine doesn't
Okay.
match it.
Oh wait, maybe it does.
Mine doesn't match it at all.
Oh wait, no, it doesn't. Well, bet.
Don't look at mine. Mine doesn't match it.
Which line
Oh,
are
so
you
you should
talking
be.
about? You dropped the line.
I mean, I'm pretty close. But like, I hate that. I am bad at this because when I get nervous, I get sassy, so I'm very sorry.
It's true you do.
We have
This one just looks big.
Yeah.
I mean, it's really small.
I'm gonna addition.
you are.
Once I do like the two lines like that, I'll do like that, right?
Okay, so
Okay, that's what I was asking.
sorry.
I don't even talk to her. I literally don't talk to her.
Is that
I had a full conversation with those guys in my
Okay,
I
so, hey, just like every other time we've constructed things, we've always had them meet somewhere, haven't we? Hey, look how these meet somewhere again. So this is going to have its own name again, just like our other things had names. This one's name is called the centroid. This one is called the centroid. Yep.
Wonderful.
Is this
Science.
Wonderful.
Okay, what's the difference between a centroid and incenter?
Hey,
Center is what we use for an inscribed triangle.
Which is
The triangle that you draw inside, or the circle that you draw inside of a triangle.
Oh.
Where the radius to the side is all, and the radius to the center to the side. Hi, Super Sassy. I'm Mr. Costa. Nice to meet you. This one?
what?
We're in playing too.
There's that one.
No, it's like purple.
Simply not purple.
Now, the significance of a centroid for us, the significance of a centroid, okay, everything has a significance in here that we've done. The one for a centroid is that it's the balance point of a triangle. So if this triangle, if we cut it out on a piece of paper and you just had that triangle with these dimensions, this would be a balance point. So if you put that on like a pencil, it would actually balance. But at other places, it shouldn't balance that well. But if you were to put it there, it would actually balance, okay, if you were to be able to balance it. It's the balance point of a triangle. So as long as it's evenly distributed weight-wise, that would be the balance point of it. It would balance,
It definitely wouldn't.
okay?
That's not how physics works.
Well, it is.
Exactly.
Fact of it.
Physics.
You can balance 3 knives on
Haley, you're missing a spelling on your.
That's stupid. I find that weird.
Okay.
That's not a thing.
It's such a bad move. Awkward.
Have you seen?
You need some of your,
You can use 3 knives to.
I don't have any food.
that's why you're in a bad mood.
I
Okay,
think it's
so,
because you're not sitting.
hey, the 3 medians of a triangle, the 3 medians of a triangle are concurrent. What's concurrent mean? No, concurrent means that's a U. They intersect. 3 or more lines intersect at the same point. They are called concurrent lines. The 3 medians of a triangle are concurrent at the a point called the, what did we say it was?
Centroid.
Centroid, very good, of the triangle. Now we have this centroid theorem, because we have theorems for all of these, woohoo! Okay? Where it states that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. What's that mean? Okay, let's unpack that a little bit. So, that means if this whole thing, if A to X, one of the medians, A to X, one of the medians, vertex to the opposite, midpoint of the opposite side, if A to X here has a length of, oh, let's call it M for now. Just a random variable. I chose M just because it's not one of these points, so we wouldn't confuse it, hopefully. It has a height or length of M there. What we're saying is that A to our centroid P, as it says here, centroid P, as it says here, A to P would be 2/3 of M. The vertex of the centroid will be 2/3 of the segment. So if the whole thing's M, A to P will be 2/3 M. The measure of P to X, the rest of it, the centroid to the midpoint, will be the remaining 1/3 of M. If you look at your triangle,
My triangle is very big.
is this exactly in the middle between this and this? It's actually 2/3 of the distance across. What? No idea. So, this will be 2/3 of the distance, this top part, whereas this bottom part is going to be 1/3 of the distance. What was that? Correct, yeah. If it's easier for you to remember, well, you can just tell, obviously, one of these is longer than the other, right? Part of the median is longer than the other part of the same median. So the longer part is going to be the 2/3 part, and the shorter one is going to be the 1/3 part. It's always going to be that ratio, though. We're going to use this and unpack it. I think it'll help us. Okay? One thing that might be beneficial for you to write off to the side, though, is like a 1/3 to 2/3 rule. That might be beneficial for you to write down to the side. It's like a 1/3 to 2/3 rule. Part of it's 1/3, the other part of it's 2/3. So if we move on right below this, in example 13, we're tasked with finding, we're tasked with saying, hey, if BF, well, first of all, I should say, these are all midpoints. F, E, and D are midpoints. We can tell that because of the fact that these two parts of the side are congruent, right? We can tell F's a midpoint. We can tell E's a midpoint because the two sides that it splits is congruent. And we can tell D because the side it splits is congruent as well. So we know they're midpoints. And we know it goes from the midpoint to the opposite vertex, midpoint to the opposite vertex, and midpoint to the opposite vertex. So we know that each one of them is a median. We have three medians meeting at point P. So if three medians meet at point P is called the centroid. Awesome. So if BF here, the entire length of this median, I said medium, the entire length of that median is 15. The entire length of that median is 15. We need to find BP and PF. We need to find BP and PF. Faith, what are you thinking? Okay, so we can say 2/3 will equal 15 over 1 because that's its proportion. Okay, blessings on F, let's forget. Okay, so we can set up a proportion, and which one would this find? If we're doing 2/3 compared to the whole thing, which one would this be finding? BP or PF? BP, the longer part, okay? The vertex to the centroid, the vertex to the centroid will be the 2/3 part. So if we set up this proportion, we could cross multiply, correct? 2 is equal to, sorry, this should be 2/3 x, or 2x over 3, excuse me. 2x will be equal to me a second.
Wouldn't it be 15 over x? Then it'd be 2x.
No. Why am I doing that wrong? Okay, you don't set up a proportion. Excuse me. I got ahead of myself. You don't set up a proportion in this one. You do 2/3 times this. You do 2/3 times that. Excuse me, not a proportion. You do 2/3 times that. Excuse me. What? 2/3 times 15 over 1. And as Ian said, it would be 10. We could also look to cross reduce early. 3 and 15, you can make this a 1 and this a 5. Questions on that cross reducing? Okay. So this then becomes 10 over 1. So the reason we multiply, I need to back that up, the reason we multiply and not do a proportion is because we're saying this top part, BP, the vertex to the centroid, is 2/3 of it. So if we want 2/3 of it, we're going to take 2/3 times that. Just like if we wanted twice the distance, we would multiply it by 2. So if we want 2/3 of the distance, we're saying we just want to multiply it by 2 over 3. And so if we do this, we found BP to be equal to 10. So with that part being said, how would we find the remaining part, PF? We could subtract and get what? 5. Could we have done it some other way? Adrian, what are you thinking?
Well, you could have done the multiplication thing again.
We could have done the multiplication thing. Instead of doing 2/3, we would do what? 1/3, because this remaining part, the centroid to the midpoint, is 1/3, and we would multiply that times 15, the same thing that we did before. That's going to be equal to, well, we could cross reduce and just get 5.
Or you can just divide in 1 divide it in 3.
Yeah, we can take 15 divided by 3, which is really the same math. Yep. But if we think about it as multiplying, it might just be a little easier for us to remember this one as well. But if that's how you remember it, cool. Question on that first one. Okay. Let's look at example 14 here. So once again, you can have 3 medians coming to meet together. Yeah, we can tell because they're midpoints going to the opposite vertex in each of these. So it's 3 medians coming together. So point P is the centroid. So we can use that 2/3 rule again. So if EP is 12. Ooh, now we need to find PC and EC. Jacob, what are you thinking?
Find PC just times by 2. Equal them
Find PC times by 2. What's your logic there?
to. Well,
I agree, but what's your logic?
if it's 2/3, you already have 1/3, you just add another third to it.
Okay.
Just times by 2.
So what Jacob's saying here is this is 1/3 of it. So if we need 2/3 of it, that's what PC is. PC is the remaining 2/3. We already have 1/3. If we're going from 1/3 to 2/3, how could we get there? We could multiply by 2, correct? So if we're going from 12 to a mystery number by multiplying by 2, we get 24, which is not as funny as 25, I should know. So the measure of PC will be 24.
And then EC is 36.
Ah,
If you add them together.
EC will be 36, because you can add them together. How could we have found EC if we didn't add? If we didn't know what PC was, how could we find EC? Jacob?
Just times by 3.
Okay, take 12 and times it by 3. Because once again, if we're going from 1/3, but this time instead of to 2/3, we're going to the whole, 1/3 to the whole, 1 over 1, we would need to multiply by 3. So just like here, you go 12, multiply it by 3, you get 36. Questions on that? Is that the same thing you were going to say?
Yeah.
Okay. Is this 2/3 rule starting to make a little more sense for us?
Yes.
Okay. Let's continue on. Vertex L is 8 units away from the centroid of triangle ABC. Vertex L is 8.8 units away from the centroid of triangle ABC. Find the length of the median that has an endpoint at L. What might help us here? Drawing a picture of a triangle here, okay? So if we have triangle ABC, it really doesn't matter what we make our triangle look like. That's funny.
Are you laughing at me?
No, I'm laughing at this because you.
Because it says vertex L and it's triangle ABC.
Yeah, yeah. So let's call this LBC.
Whoever made this
I think-
is smart.
I did not catch that the first time we did this. Okay. So now we have all three medians meeting at the centroid. And our centroid, we don't know what it's called, that's okay. So we know the vertex L to the centroid is how long? 8 units. So we need to figure out the entire length of the median. Do we have the 2/3 part or the 1/3 part? So this is where it might hurt us if we just remember long and short. So we actually need to remember that vertex to centroid is the 2/3 part, which we have. Whereas midpoint to centroid is the 1/3 part. Yes.
How do you know that 8 units isn't the small part?
Because it says it's from the vertex to the centroid. And vertex to centroid will always be the 2/3 part. Always, always, always. Good question. So they said, hey, how do we know it's not the small part? The vertex of the centroid will always be the 2/3 part. The midpoint of the centroid will always be the 1/3 part. If you need to jot that down, I would recommend that. If that's something that you're like, oh, I didn't think about that either. So, if we're trying to find the whole thing, how could we go from 8 being the 2/3 part to finding the whole thing? Ian, what do you think?
Divide 8 by 2 so it's the 2/3 part.
Okay, so divide 8 by 2 to get it to just being 1/3,
Yeah.
and then what?
Then you times it by 2. 4, 3.
And you times it by 3, okay? So is that the same thing as if we had multiply 8 times what? 3/2?
Probably.
Yeah, reversing it.
Can you set a proportion? Because that's what I
What's-
did.
What's
and
your
I
idea
got
for proportion? What do you have?
2/3 equals 8/x. X equals, that's so much easier.
Let me think about if that math works out that way all the time. Yeah, that would work. It's mathematically equivalent.
Is that just for like this one that is a
Nope.
coincidence, or is it like that?
It's mathematically equivalent, so it'll be the same.
Okay, cool.
Yep. Because that's what I was doing there. I was checking it out just to make sure it would be not just a coincidence. So, because if you reciprocate it, it's the same, and it's mathematically equivalent.
Okay.
That's what you need to know. Okay, so you also could have set up this proportion where this is a 2/3 part, so you put 8 over the entire thing. We need to find this much. We could have done as well. Does it make sense though? Why Ian said, hey, if we divide this by 2, we get 1/3. So we know this is 4. And we add the 8 and the 4 and multiply by 3.
Do we need to know the whole thing or just the other part?
What did it ask from us? Find the length of the median. So yeah, we do know the whole thing. Good question though. That's why we read those. That's why we're like, oh, what do we need to find? Any questions on that one? Okay, let's continue. So if we're supposed to do this graphically, try to do this graphically here. And that just means by way of a graph. Okay, by way of a graph. Okay, by way of a graph here. Then, so what we're going to be doing is we're going to be doing very similarly to what we did on other things. By this time, we already had the triangle graphed out here. So we need to find the midpoint. Just like we found the midpoint by construction, we can find the midpoint when we're given points. Remember, the midpoint is like the averages of the points. So if you take half of the x sum and half of the sum of the y's, you'll get it. So if we find the midpoint of QR, there's a couple ways we can do it. We can first take the x's, add them together. 0 plus 6 over 2, and 8 plus 4 over 2. Get 6 over 2, 12 over 2, and get 3 comma 6. Hey, Ian, how did you know it was 3 comma 6 before I got there mathematically?
I don't know, guys, man. In my head.
Hey, did you do the same adding and stuff? Or did you do something different?
No, that's what I did.
Oh, okay.
I just like.
Okay. Evan.
I knew it was 3, 6 because 3 is in the middle of 0 and 6, and 6 is in the middle of 8 and 4.
Okay, we can also go with what number's in the middle between them. So the 3's in the middle between 0 and 6, so it has to be 3. And then 8 and 4 in the middle of 6, so it has to be the 3 comma 6. So Evan said, hey, we can look at this graph here and these points and just say, oh, what's the number between those? So if that's easier for you, just say, hey, what's the number between them? What's the middle number between 0 and 6? Go ahead and do it that way. If that's easier for you to do, go ahead and do it that way. That's what I was wondering if that's what you were thinking.
And I kind of knew it was 3, 6 because it only crossed like through 3, 6.
Yeah, that's true. So now what we'll do is we'll connect this midpoint to the opposite vertex. So I'm just going to do a dashed line on here. So we're constructing what we call our median, right? It's the midpoint of one side to the opposite vertex. Midpoint of one side to the opposite vertex. Instead of this time, we just did it with points on a graph rather than constructing the perpendicular bisector, finding a midpoint. So we could also find the midpoint of QP. What would be the midpoint of QP? Take a second to figure it out on your own. By whatever method you want, midpoint of QP. Take a second to figure it out on your own by whatever method you want.
We need to do it for our.
And yeah, go ahead and do the midpoint of RP as well. Does somebody want to tell me what the midpoint between QP it would be?
QP.
Yeah, Evan, go ahead.
1.5, 4.
1.5 comma 4. Okay. 1.5 is halfway between 0 and 3. 4 is halfway between 0 and 8 for the y's. And we need to once again connect that to the opposite vertex to construct our median. And should we already have an idea of where our centroid is at after 2 of them? Yeah, we could do the third one to check if we need. But we should already have an idea. That should be what, Ian? 4.52. 4.5, comma 2. So this one you'll definitely want to remember for. And they should all intersect at one point. And it should be the same point they intersected at the first one. So our centroid, we'll write it as an ordered pair. Step 4 would be writing as an ordered pair. What is our ordered pair where our centroid is at?
3, 4.
3, comma 4. And that would be our answer if we're trying to find the coordinates of the centroid. Questions on that?
So we just put cent.
Yeah, let's put centroid. Thanks for asking them. Okay. So we're going to move on from centroids, using medians to find centroids. We're going to use altitudes to find orthocenters quickly. And we're actually going to bypass the construction for this one. I feel like we've done enough construction for today in this unit. In general, we're going to bypass that one. So, an altitude is a segment that's from a vertex of the triangle to the, what's the exact word? From the vertex of the triangle, and it's perpendicular to the opposite side of the triangle. Or it's a new line that contains the opposite side. We'll talk about that second part there. So the altitude goes from the vertex again, just like the median went from the vertex, but this side, instead of going to the midpoint and not necessarily being perpendicular, it goes to any point, but as long as it makes the right angle with that opposite side. So it still goes to the opposite side, vertex to opposite side, or opposite side to vertex. But in this side, instead of making a midpoint, it goes to just where it's perpendicular with it, which is not necessarily the same spot. Is this at the midpoint right now? No. So it doesn't have to be the same spot. Now, an altitude can lie inside the triangle,
Or
outside the triangle, or, oh, I missed. Actually that one's outside. So outside the triangle, but the second blank there I skipped over somehow, is on the triangle, which is our third one. So in each of these, what is our altitude? It goes to make a right angle, but the altitude is this line here, this segment here. So what segment is it? Segment AB, that's what I was looking for. So segment AB is altitude. The altitude is a segment. Just like the median is a segment, the altitude is a segment. Just like perpendicular bisectors and angle bisectors are lines, or rays, or planes, or segments. Medians and altitudes are segments. Now, notice here. I don't think I have it. Oh, okay, never mind. I haven't noticed that yet. Questions on this part? Okay. So when it said here at the bottom, to the opposite side or to the new line containing the opposite side, that's talking about like the second example here. The second example here, where it had a new line that just kind of extended from this. Can you kind of see how this is extended from this bottom side? So it's just a new line containing it, that's extended from it. That's all that means. So sometimes we have to do that to make it perpendicular, because there's nowhere from here to any of this that it'd be perpendicular. So if we continue on, we'll skip that constructing an altitude part. So the three altitudes, if we were to have constructed them, they would have ended up being concurrent, just like all of these have been concurrent at some point, at a point called the orthocenter. Point called the orthocenter of the triangle. We'll have a graphic organizer for him to help us. So the orthocenter can be inside, on, or outside the triangle. So just like the altitude can be inside, outside, or on, the orthocenter can be inside, outside, or on. And if we think about that, if orthocenters can be outside, or sorry, if altitudes can be outside, like on this two slides ago, if the altitude can be on the outside, then the orthocenter has to be able to be on the outside where the three intersect. Questions on this, or anybody still need this part? Okay. Okay, we're almost done, guys. We're almost done. We're getting there. No, it's been a long one. So for acute triangles, where does it look like your orthocenter is? Inside. That was the same thing we had for the circumcenter. Circumcenter was the other one we learned that they can be in different places. Circumcenter was also inside for acute triangles. For right triangles, where does it look like your altitude is? Or our orthocenter is, excuse me, on the triangle. And our obtuse triangle, where is the orthocenter? Outside the triangle. Triangles in the dark blue, the altitudes are in the kind of that seafoam green. That's color.
It looks turquoise. I see from one. Yeah,
That's like the same.
it's more. No, it's not. That one's dark. It's like a darker green. Yeah. So turquoise. That's not what turquoise is.
They're pretty close, but yeah, I can get it. This is seafood green.
Dude, that sass was my favorite.
Okay, talk me. Gonna switch you back classes now.
Oh, that was a love of.
Oh, okay. So we're gonna find the orthocenter by graphing again. So just like we did the centroid by graphing, we're gonna find the orthocenter by graphing. So our first step is going to be to graph the vertices. We first need to get the vertices on the paper. So we graph the triangle, label the vertices. And then we'll connect them. So the altitude here, remember if we recall, like we just said a little bit ago, the altitude goes from the vertex to be perpendicular to the opposite side. So that means the altitude is perpendicular to a side. What do we know about perpendicular lines? What do we know about their slope?
Opposite reciprocal.
They're opposite reciprocal, okay? They're opposite reciprocal of each other. Slopes are opposite reciprocal. Opposite sign, reciprocal to flipped version. So what we're going to need to do is we're going to go from the vertex to where, and if we know, if we don't know where point it's going to be at on the other side, we can find it out. And the way we're going to find it out is we're first going to find the slope of one of the sides. So let's find the slope of OPR. So I should write that differently, excuse me. So M is our slope. So I'm going to write this as a big M, a small PR. Not to confuse it with the measure of PR, which we would write this way. The measure of PR would be written a small m, a big PR, with the m kind of at the bottom. This is the m's at the top. We're talking about the slope. If it helps you, just write slope too instead. You can just write slope if that helps you. Keep it straight. The slope of PR will be what?
2.
Okay, 6 over 2, which simplifies to 3 over 1. Questions on that one of how we got that? Okay, we do rise over run. So it rises 6, runs 2. 6 over 2 simplifies to 3 over 1. So if we're looking at the slope of a line that would be perpendicular to that, instead of 3 over 1, it would be negative 1 over 3. Opposite sign, reciprocal. How long has he been there?
I have no idea. I just
Long
saw it.
time.
You been there a while? No. So we found the opposite reciprocal of the slope of PR. So that means it'll go from the vertex opposite this line using this slope. So what's the vertex opposite the side PR? What's the vertex that's opposite this side?
Q.
Q. Okay, we'll go from this vertex Q using this perpendicular slope. So for every 1 I go up, what direction do I go 3? Left. You could go down, and then you go to the right 3, correct? But we need to go to the other side. We need to go from the vertex to the opposite side. So then we go up again 1 over 3, and let's make a line there. And that'll be perpendicular to that side. So that's our altitude. It goes from the vertex to be perpendicular with the opposite side. Now we only actually need to do it for one other side. We only need to do it for one other side, like we said with the centroid. We only need to do it for 2 sides. But it's a little bit of a simpler process with the centroid than this one, I think. So this one we'll actually just do the 2 sides. So what other side do you want to find the slope for and do the perpendicular one? You want to do it from point P to RQ? Why that one, Ian? It's easier. What's the line going to be perpendicular to RQ? Alright, it's going to be right here. But what direction will this be going? Straight up and down. Okay, here's the thing. What's perpendicular to a straight horizontal line? A straight vertical line. So if we're trying to find altitude, we're trying to find perpendicular, it will be easier for us to pick something that's straight up and down or straight left and right. We kind of jumped through that part pretty quickly. Questions on that second one and why we chose that second one. The second one to be side RQ as opposed to side PQ. Okay, so our orthocenter is at the ordered pair where those meet. At 2, 2. Questions on that? That's kind of a weird process in O'Haley, yeah.
How did you get the up and down line?
This one?
Yeah.
Okay, so the first line make sense?
Yeah.
Okay, so we're going to repeat the process for another side because we made one altitude, but it's where 3 altitudes meet. So we need at least one other one. So we said, okay, for us, it would be easier to choose this side than this side because if we're finding the perpendicular to one of those sides, it's easier to know where the perpendicular, what direction the perpendicular side will be going if it's straight left and right or at an angle. Straight left and right. So we chose RQ there. And so what's perpendicular to a straight horizontal line? Vertical line. And what's the opposite vertex from this side, RQ? P. So we connected it there. And we went straight up and down. Does that make sense? Okay, good question. And what kind of triangle is this one? Acute, obtuse, or right? Acute. So the orthocenter should be inside, on, or outside? Inside, and it was. Okay, what we're going to do is I'm going to call it there, and I'm going to pass it some homework, okay? I'm going to call it there, I'm going to pass it some homework. Call it then. Yeah. I call Mr. Rodriguez. Wait a few minutes. She might still be teaching.
She's probably just telling another story.
I mean, she could be, but.
I know.
Oh, okay. Can I get a volunteer to pass these out? Okay, Gage.
Did you know I got yelled at for having a sticky note one day? Miss Caniglia.
Oh, really?
Yeah.
Was that not good enough?
Apparently not.
That's good to know.
I'm probably gonna get yelled at for this one.
No.
Probably.
Okay, good talk.
Oh, there's some we gotta cross out. There's always some we gotta cross out.
Which ones are we not doing?
I'll get that in a second.
Yeah, it's like my favorite problems are.
Double-sided.
Double-sided.
Double-sided?
You want the rest?
Yes, please. Just go and set it here.
Yeah. Oh my gosh. Okay.
Go ahead and start at the beginning. It won't affect it.
He says that for the
Good talk. Oh yeah, it's supposed to be triangle DUF.
I'm gonna fight you.
Yeah, I corrected that on mine.
I'll tutor you. You should sign up.
Three,
Mr. Canero has to email me back. I wonder why. Sign up, Joe. I'll tutor you. Yeah. That's true.
Okay, so I got some don't do's. Yeah, but it won't affect the ones you did, I'm sure.
I haven't started. Whoever does want to.
Wait, how do you find the perimeter?
So, don't do's.
1, 2, 3, 4. Oh.
Hey, for these, I want you to flip through the paper as we do them, okay? So on the first page, the only don't do is actually number 10. Okay? Okay, the first don't do is number 10. So you flip the page.
There are a lot of not.
On this page, don't do 17 through 20.
Bro, that last.
Okay? On the next page, there's another 20 and 21, isn't there? Okay, I want you to do those, but I don't want you to do that 22 at the top right. Nor do I want you to do
There's no 20 on 20.
Yes, there is.
Oh,
There is.
yeah.
This is cut off.
It's-
This is cut off.
it's three-hole punched. It says use a diagram below to answer questions number 18 through 19. That got misnumbered and it didn't get changed. So it's just those diagrams for these two right here.
Don't do 22 though.
Don't do that 22 in the top right, and also on this page, don't do that 23 through 26 at the bottom. And then on the back, don't do that 31.
Don't do the 30.
31, the very last one.
27, 30, basketball.
Okay. Hey, and in a lot of places, like on right, like one of the very first instructions, it says P is the centroid of D, DEF. I don't know why in the world it changed from a triangle to a D, but it did. It should be triangle DEF, not D, DEF. And that happens a few other times in the worksheet. So anytime you see where it says a D right before three letters, where you think it should be a triangle, it's a triangle. It happens a few times. It's really annoying. Sure. That's what I'll say here. It says D.